All right. Number 11. 4 3/10, 4 7/8, 4 8/10, and 4 1/2. Okay, these are all the numbers we have. Denise marked and labeled these numbers on a number line. Which number did Denise mark and label closest to 5? Okay, so I'm looking between 4 and 5. The one that would be closest to 5 would be one of the largest. So the first thing I'm going to do, I see these are all mixed. I'm going to go through and convert my fractions to decimals, okay, to accurately compare them and place them on my line. Okay, we already have 4.3, so I need to convert 4 7/8, all right. 7/8 means 7's on the inside, 8 is on the outside, all right. 8 does not go into 7, minus 0 leaves me with 7 still. Drop your first 0. 8 goes into 70. I know 8 times because I know 8 times 8 is 64. And adding one more 8 would go over. You can use your top-bottom chart, multiplication chart, or you can guess and check and list the multiples. Okay. So 8 times 8 is 64, so I'm going to subtract that. 70 minus 64 leaves me with 6. Okay. I'm going to add my second 0 in the hundredths and drop it. 8 goes into 60. I just said times 8 was 64. I need to drop it by 1. So this is going to go in 7 times. I know 8 times 7 is 56. You can use your multiplication chart or multiples. Okay. 60 minus 56 is 4. You can go through and borrow if you need to. Okay. I still have a number down here, a remainder. So I'm not done because we don't use remainders. We use decimals. Going to add my last 0 in the thousandths and drop it. 8 goes into 40 exactly 5 times. All right. So 7/8 is 0.875. All right. That would make this, remember, it already has a whole number, so it's not 0.875. This is now just 4.875. Okay. You could also use your Texas method to convert this to a improper fraction and then divide. You would get the same answer, but your 4 would end up in your wholes place in the first place. Okay, then we have 4.8. Then we have 4 1/2. I know a half as a decimal is 0.5. Okay. If you need it proved to you, I will come down, do it on the side. All right. 1 in the inside, 2 on the out. 2 does not go into 1. Drop my first 0. 2 goes into 10 5 times exactly. Okay. So 4.5 is really 4 1/2. All right, from here, I need to go back to my original question. I've done a lot of work, but I need to know, or I need to find, which number Denise marked and labeled closest to 5. Okay, closest. So I'm going to go place them. I know that 4.5 is right in the middle, a half. So I'm going to go through and mark that one. It's a benchmark. So I'm going to go through and mark my half. All right, and then I'm going to start over. So from the beginning, 4 3/10. I know that's going to be to the left of 4.5 because 3 is less than 5. So I'm going to scoot it over just a little bit. Okay. And I'm going to call this 4.3. Okay, because I still have to have room for 4.1 and 4.2, 3, 4, 5. Okay. And continuing, I have 4.875. So if I have my 5 here, I would go 0.6, 0.7, 0.8. But then I have a little bit more after that from 0.75. And then 0.9's over really close to it. Okay, so this is 4.875. It's closer to 5 because that 8 is really big. Okay, and then I have 4.8. All right. 4.8 is the same as saying 4.800. So it has 8/10, but no hundredths and no thousandths. So it's actually a tiny bit, like the tiniest bit less than that 0.875. Okay, so it's going to go right to the left. It's a little bit less, but really, really stinking close. All right, and now I'm going to go in order. If number lines don't help you visualize it, you can list your decimals vertically and check them the same way, looking for the biggest one without going over 5. The one closest to 5 in this case ends up being 4.875. That's not an answer choice. I need to go back and find its original, which is 4 7/8. So this would have been B.